We're going to jot down, again, we're not going to do any formal proofs in this section, but these are kind of obvious, huh? We're not doing any formal proofs this section. It's the only ones that come from this chapter are from 2 and 3. Okay, so theorem 3.8 states the following. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So let's think about this. What does it mean to have a linear pair? You might have just written it on your blue paper. If a linear pair, then what?
A congruent 90 degrees.
What's the linear pair?
Linear, I don't know.
They're supplementary, right? They add up to 180. So if we had two lines intersecting to form a linear pair, so here's a line, there's a line. If my two lines ended up having congruent angles, what would need to be true about these two angles if they were the same? What degree would they have to be? Yeah, they would have to both be 90, right? Because if this is 90 and this is 90, 90 and 90 are the only two angles that are the same that add up to 180 degrees. So because they would be 90 degrees, isn't it true that those two lines would then be perpendicular? Yes. Okay, so if two lines intersect to form a linear pair of congruent angles, then the lines, Jared, I think you're the one that looks a little distracted. Then the lines are perpendicular. Okay, next one. If two lines are perpendicular, then they intersect.
To form 4, right? Are you recording?
Yes. Then they intersect to form 4 right angles. Question?
Who needs one?
I'll get him one at the end of class. So now let's think about this. If I've got two lines that are perpendicular,
Then there's 4 right
that angle is 90 degrees. What would be the measure of angle 1?
190.
Why?
Because the other one's 90 and it has to equal 180.
Why do they have to
on the
equal 180?
Because that is a supplementary.
Why are they supplementary?
I don't hate
Because they're
180.
perpendicular. Because they're straight. I don't know.
What type of angles make a straight angle? What do we call that?
I don't know.
A linear pair. Did we just talk about the last one? So angle 1 would have to be 80 degree or 90 degrees. What would be angle 2? Why? Because they're a linear pair. What would be angle 3? Or vertical angles also could be congruent, right? Yeah, either one of those would work. So if two lines are perpendicular, then is it true that all the angles around are going to be right angles? Yeah, and we kind of already knew that. We didn't need a theorem to tell us that. But now we do have a theorem that's telling us that. So in our first example, we are told that line AB is perpendicular to line BC. So what can we conclude about angle 1 and angle 2? So angle 1 is congruent to angle 2. What else can we conclude? Angles can't be parallel. They are a linear pair, so angle 1, let's do this. The measure of angle 1 plus the measure of angle 2 should equal 180. True? What else can we conclude? So if they have to be a linear pair, and they're congruent, what did the first theorem 3.8 tell us needs to also be true about them? That just tells us lines are perpendicular. So what else does it tell us in 3-9? They would be what type of angle? Right angles. Good. So the measure of angle 1 is equal to 90 degrees. The measure of angle 2 would equal 90 degrees. So those are all the things we can conclude. So angle 1 and angle 2 would both be 90 degrees. They're congruent. They are supplementary, which means they're a linear pair. Okay? Simple enough? All right. Theorem 310 states if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So let's dissect that. Complementary means what? Adds up to 90 degrees, right? What does an adjacent angle look like? They're right next to each other, right? So if I have two adjacent angles whose sides, so here's angle 1, here's angle 2, so they share a common side. If their sides end up being perpendicular, that means that this would have to be a right angle, and then these would then have to be complementary, right? That's what this theorem is telling us. So let's flip on to the back. So given that angle ABC is congruent to angle ABD, so this angle is congruent to, let's get a different color here, that angle. Because they are congruent and they are a linear pair, what is true? Because they are congruent and form a linear pair, theorem 3.8 tells us what? Nope.
They'll be per.
They are perpendicular. What's perpendicular?
The 2 lines.
So AB is perpendicular with CD,
Yes.
right? Since these are congruent, my green angle and my red angle, and they are a linear pair, then these lines need to be perpendicular. So that means I have a right angle here, so what should be true about 3 and 4? What did theorem 3.10 tell us? What should be true about 3 and 4? So angle 3 and angle 4 are complementary. Say it again, Riley.
Angle 3 is perpendicular to angle 4.
Well, no, it's not perpendicular to each other. They're complementary. So it means that they add up to 90 degrees. Or if you wanted to write it out as the measure of angle 3 plus the measure of angle 4 equals 90 degrees, that would also work for an answer. Either of those I would accept. Okay? All right, 2 more. And these are kind of converses of each other. So now we're going to bring that transversal concept back into play. So theorem 311 says if a transversal is perpendicular to one of two TWO parallel lines, then it is perpendicular
Per.
to the other.
I'll try this puppy, huh?
So let's dissect this one. Here is a line. Here is another line. What markings do we put on them to show that they're parallel? The little arrows. Good. If my transversal, which I'll make green here, that wasn't very perpendicular. That's a little better. If my transversal ended up being perpendicular to that first line, what degree you would be the angle that my arrow is pointing to? Y.
It's the same.
If parallel lines, then y is that 90 degrees. Because they're corresponding. Good. If lines are parallel, then corresponding angles are congruent. So if the top half is 90, the bottom half is 90. So if a transversal intersects parallel lines and it's perpendicular to one, then it must be perpendicular to the other. Okay? And then the next theorem is just kind of the flip of it. If two lines are perpendicular to the same line, then they are parallel to each other. Okay. Now, these were a whole bunch of theorems that we just went through. Because we're not doing formal proofs for 3.6, I would not put these onto your blue sheet. It would just be wasting space. Okay. All right, so let's finish up with the last two examples here. The first one is quite simple. We need to decide which lines are the parallel lines. Well, you would say, Mrs. Crowley, they all look like they're parallel lines, but they're not. Let's start with P and Q. If I scroll down P and Q's line, are they both perpendicular to line U? Do I have right angles here? No, I don't have the little boxes, so don't assume right angles unless the boxes are there. Are they both perpendicular to T? No. Are they both perpendicular to S? Yes. So if two lines are perpendicular to the same line, then they must be parallel, which is what that theorem is that we just wrote. So I would say something like P is parallel to Q because they are both perpendicular to line S. Now let's check the other ones. Is U going to be parallel to anything? Why not? It doesn't have any perpendicular markings at all, right? So U and T are not perpendicular because not perpendicular, not perpendicular. U and S are not perpendicular because they don't are parallel, sorry. Not perpendicular, not perpendicular. Let's check S and T. Are they perpendicular to the same line? Yeah, right here, line Q. So I would also then say that S is parallel to T. Yep, because they are both perpendicular to line Q. Okay. And our last example is probably going to be our toughest example of this section. So we have to bring back the distance formula into our lives. Does anybody remember the distance formula? That's slope. Big square root 1. AD equals the square root of something.
Negative
Emily had it. Distance formula, we don't want to lose that one. That one comes back into our lives quite a bit throughout this whole entire course. Let's flash back to chapter 1. So go ahead and get your distance formula jotted down. So now we're going to talk about distance between two things. I want to find the distance that point A is from C. Now I want you to watch for a quick second. Don't put anything in your notes. If I wanted to find the distance, would I measure maybe from up here to A?
Sure.
But what about if I go from here to here? Isn't that a different distance?
Sure.
So if I go from here to here, that's a different distance. So how do you measure distance? Like if I'm standing here and Zach's back in that room, if I were to measure the distance between the two of us, I wouldn't go up that way and over that way.
Can't you just pick anywhere on the line and simplify it?
I can't pick any point on the line, but the shortest distance is going to be the perpendicular line. Okay, guys, please pay attention because this is the hardest problem in this section. So you need to figure out what the perpendicular line is going to be that goes through A and is perpendicular to this line. And we just did this.
You have to go down one left, one down, one left, one.
So my slope on this line is -1.
Still failed that test.
So what's my perpendicular line? +1. Okay, so now what I want to do is I'm going to make a line from A that's going up 1 over 1, up 1 over 1, up 1 over 1. But I don't care about anything up here because I want to just know the distance between the two lines. So go backwards. Go down 1 over 1, down 1 over 1, and make a line segment. So now I need to find the length of that line segment, Jared and Kai. To find distance, I need to find coordinates. What are the coordinates of point A? Is 1, 2. What are the coordinates? Let's call this point B for fun. What are the coordinates of point B? Good. So now we got to plug those into our distance formula. So I get the square root of my x sub 2 is what number? X sub 2? -1 minus my x sub 1, which is 1 squared, plus y sub 2, Jared, is... What's my y sub 2?
Oh, your y sub 2 would be, I don't know.
0
0, 1.
minus 2, y sub 2, and y sub 1. Your y values are 0 and 2. Squared. All right, order of operations tells us to work inside parentheses before we do exponents. So -1 and -1 makes -2. -2 squared is +4. 0 minus 2 is -2. -2 squared is +4. 4 plus 4 is 8. Square root of 8. Do you guys remember simplifying your radicals?
Yeah.
What perfect square goes into 8? 4 and 2.
Yeah, 2 square root 2.
2 square root 2 is our answer. Good. Okay. All right. So